Hello, and welcome to the third episode of Tips and Tricks in AWS from a full stack developer. To quickly get off the mark, as there is a lot to elaborate in this episode and it can get very complex. A very natural question when using a custom bucket class is why not use the iBucket interface and get everything done through the interface's members? I'm assuming that the previous two episodes justifies the question without any premise. The answer to the question is simple. Implementing the iBucket interface would mean inheriting many undesired members into our bucket class. But let us go ahead and implement the interface anyway and define the bucket name member as a public read-write property. To demonstrate why the iBucket interface cannot be used for our requirement, that is, to rename the bucket with a user-friendly name, if you find the introduction of the requirement is out of the blue and without any context established, please watch the two previous videos to get the context. I will remove the ICFN bucket reference from the bucket props class. If you recall, from the previous episode, we had used the interface to successfully rename the bucket and deploy to the AWS CloudFormation. So we'll modify the myBucket variable to be of type iBucket because we want to find why usage of iBucket interface would not be conducive for this particular purpose. Plus, we have uncommented the public bucket name property in the class initializer in our stack class. The props.props parameter shows a squiggly and the bucket name in the stack class still shows it is a read-only property. Anyway, from the previous episode we know how to resolve the props.props error. We simply make the S3 bucket props class implement the iBucket props interface and the error is resolved, but the bucket name property still shows read-only. And checking the other public members, we find that all the properties are read-only and that props.props.bucket name is read-write because we have declared that variable in the bucket props class. So let us comment out the bucket name in the class initializer and not inherit from deputy base to find out from CDK as to what the problem is. CDK tells us the error is the same that I had demonstrated in episode 2, that of the JSI runtime not able to resolve the arguments that it expects as TypeScript would. So let me add the deputy base class in the inheritance hierarchy and recompile. But now another error appears which is related to iBucket props. So let's remove the interface. Not. The error is not resolved because the third parameter in the stack class expects a bucket props or an iBucket props type. So let us do a quick fix that we Indians call as jugaad and change the props.props into a new bucket props object and assign the bucket name in the initializer. Now everything is hunky-dory. .NET compiler is happy and so is CDK. Deploying the stack to the cloud formation, we find that the bucket name 2 is as desired and specified in the stack class. So is everything good? Using the bucket props as the third parameter appears to have solved the problem, right? Not so. What this solution exposes is the design. The client program that contains the stack by passing the stack props object actually has no say in the matter. The stack has coolly created a new bucket props object just because it wanted to assign a new name to the bucket. You might be wondering how the encryption property got inserted. Well, I just got a little ahead of myself, so let me redo the code to be in sync. The client now needs the bucket to be encrypted, so we create a public encryption getASetter property in the bucket props class, and in the main method we assign it the value of enum type and specify the keys as a value with the help of the bucket stack props object. This is the fundamental purpose of this design. It allows the client to not depend on the stack to do everything, because each time the bucket requirements may differ, like in a data lake where more than one bucket can get used, or if you wish to allow different customers to download from a bucket, you may want a different configuration for each customer. Now the stack class doesn't specify encryption as KMS, but instead uses the stack props object to retrieve the value specified in the main method, that is the client, and assigns it to the encryption property in the class initializer. Simple, isn't it? Let us do a quick debrief of the current state of our CDK program. This is how the main method now looks, with a bucket stack props object initialized and used to set the encryption value for the stack to use, and passes the same object into the stack props class. The stack props class as of now uses a new bucket props object to assign the user-friendly bucket name and set the bucket encryption to the value already set in the props.props instance from the main method. The S3 bucket props class inherits from the deputy base class and the bucket interface. So this is the current state, and now we go into a refactoring mode and we will get to see how the iBucket is not the most preferred interface to use in this scenario. I have now changed the names of the stack and the bucket name to indicate they are SSC encryption related, and modified the third parameter to props as is the requirement. The modification introduces same error and I am using the explicit class just to demonstrate the additional option, but the public properties are still read-only because it is an L2 construct. You know what to do now. Change the bucket and the interface to be of CFN type. Now that the construct has changed to L1, the bucket name property is available for write, but the encryption property name in the CFN bucket class is different. So let us change it in the stack and the bucket props class. It is good enough for the .NET runtime, but CDK has other ideas because the JSII runtime now cannot resolve the encryption type, and it says that either the object should implement iResolvable interface and the object should resolve the context by overriding the resolve method, or it should be of iEncryption property type. So let me do the appropriate changes to the main and the S3 bucket props class. Instead of setting the bucket encryption type in the main method, we assign the entire bucket encryption property object. The style of the initialization of the object is similar to how it is done in the base TypeScript implementation. This is the most important tip to carry with you when working with AWS CDK. When an object creation assignment is not clear in C# mode, refer to the AWS docs for the TypeScript class or implementation, and you'll know how it should be in C#. Now CDK is satisfied and the stack gets deployed. So this was the story of iBucket, L1 and L2 constructs and how CFN types are more friendly than the L2 level constructs. Another important tip while we are on constructs: when using the CDK init command to generate a boilerplate template, remember that your project would have a reference to the base construct class, and because the AWS CDK keeps getting updated more frequently, the resulting version conflicts and the compatibility problems between class libraries and the CDK will cause nightmares resolving. So you'll always be better off creating simple console app projects or even working with simple folder structures from VS Code than use CDK init. All you need to do is create the one-line JSON element shown in the second episode in the cdk.json file to refer to your compiled binary, that is the DLL, and you'll be up and running with AWS CDK.NET. In the next episode, I'll introduce and demonstrate some more CDK related aspects. So stay tuned, stay safe, and enjoy the weather.